Hi, welcome to our first lesson for 4.4 problems in two dimensions. In this video, we're going to learn how to solve triangles, both right triangles and oblique triangles. Oblique just means that some of the angles won't be 90 degrees inside the triangle. Now, how do we solve those oblique triangles? Well, we're going to have to use cosine law and or sine law to solve those. For the right angle triangles, well, that's pretty easy. We can just use our primary trig ratios. In other words, we can just use SOHCAHTOA and also Pythagorean's theorem. So we're actually just focusing on this success criteria today in this lesson. The second one that's listed is actually for the next section. So it's very similar, but it just takes things a little bit of a step further because we'll be working in a three-dimensional setting. Today, we're only working in a two-dimensional setting. I'm just going to read this first success criteria out, and then we'll start the first example. So it says, I can pose problems involving right triangles and oblique triangles in two-dimensional settings and solve these and other such problems using the primary trig ratios, the cosine law, and the sine law. We'll talk a little bit later in this lesson, the ambiguous case, which can show up when we're only given certain information. All right, so if we have a right angle triangle, we're going to be using the primary trig ratios to solve. That basically means we can use SOHCAHTOA. Okay, we can also use Pythagorean's theorem. I'm just going to write PT. Okay, now for oblique triangles, this is non-right angle triangles. So we're going to either use the cosine law and or the sine law to solve those. Okay, let's get started. So it says solve a problem using the primary trig ratios. Bassarudin needs a new rope for his flagpole, but is unsure of the length required. He measures the distance at 10 kilometers away from the base of the pole. From this point, the angle of elevation to the top of the pole is 42. So the angle of elevation, that's always referring to an angle that's measured above the horizontal. Okay, I'm just going to add that in here. It always means above the horizontal. Okay, so it would be this angle right here. And yes, this is a right angle triangle because it's a flagpole and it's supposed to be standing straight up, perpendicular to the ground. So we know we can just use our primary trig ratios to solve for this. So what is the height of the pole to the nearest tenth of the meter? So we're looking for the height of the pole. So our solution. So I'm just going to look at this triangle here and I'm going to think about what I'm given and what I'm looking for. So I have this angle here, which is good. And I'm missing the opposite side and I'm given the adjacent side. Okay, so what trig ratio uses opposite and adjacent? So just kind of recall your SOHCAHTOA, and we know that tan uses opposite over adjacent. So I'm going to start off by writing tan 42 degrees. It's going to equal opposite over adjacent, so it's going to equal, I'm going to call this height h. That's my unknown, the height. So we'll say h over 10 meters. Okay, solving for h, I can multiply both sides by 10. That cancels that out, and I multiply this side by 10. So I have h equals 10 times tan of 42. Okay, make sure your calculator is in degrees. Okay, so we'll do 10 times tan of 42. And I gotta switch mine to degrees. And we have almost exactly 9.004. It says to the nearest tenth of a meter, so we can write 9.0 meters. So that would be the height of the flagpole. Okay, part B, it says how much rope should Bassarudin buy? Justify your answer. So now we're looking for the hypotenuse. Okay. So actually, the rope for the flagpole, the rope should probably be actually the height of the flagpole because you pull on the rope to lift the flag. So, but I'm pretty sure that flagpoles actually loop around. So probably need about double. So usually the flagpole, change colors here, kind of begins here, and then the rope loops around and comes back down to the bottom. So it needs to at least be able to go all the way up to the top and back down, and probably have a little bit of slack in order to move through. So I would say 9 times 2 is equal to 18 meters. So 18 meters is like the exact length that's needed, but probably want a little bit extra. So I would say he should buy 19 meters of rope. Okay. So that way there's a little bit of a meter extra if he needs a tiny knots or anything else. Okay, that's it for our first example. And when you go to start your homework, you're going to be seeing questions that involve right angles also. And remember, you can just use SOHCAHTOA, or you can also use Pythagorean's theorem. Write that out real quickly. A squared plus B squared equals C squared. And remember, C is the hypotenuse, the largest side. Okay, that is it. And I'll see you in the next video.